Hey everyone, today let's try to solve the problem called Power of Heroes. So in this problem, you are given a zero index of integer array nums representing the strength of some hero. The power of a group of heroes is defined as follows. Let I, 0, I1, all the way to ik be the indexes of the hero in the group, and the power of this group is the maximum of everything inside the group square times the minimum of power in this group. So to return the sum of the power of all the possible groups, let's take a look at the first example. So in this example, the numbers is 2, 1, 4, and the output is 1, 4, 1. Why? Because essentially we can treat all the groups at a bit number 0, 0, 0, 0, 0, 1, and 0, 1, 0, and 0, 1, 1, and all the way to 1, 1, 1. So in this particular case, this 0 represents to the 2. If it is 0, then it means that I don't want to include this 2 into the group. If it is 1, then it means that I want to include this position which represents to 4. I want to include that 4 into the group. So this 0, 0 is not possible because we want a non-empty group. So we don't care about that. And 0, 0, 1 represent to 4. It's just this group. And this 0, 1, 0 represents to just the second one, which is 1. And this 0, 1, 1 represents to the last two 1, but not the first one. So it's 1, 4. So we iterate every group, and the first group we see here, 2, will get us a sum of 8 because 2 is the maximum here. So 2 square and times 2 is also the minimum here. So 2 to the power of 3 basically. So we get us 8. And the second group is 1. 1 is the maximum and also the minimum. That's why the answer is 1 to the power of 3, which is also 1. And 4 is also the maximum and also the minimum. That's why we should return 64 because it is 4 to the power of 5 and 2, 1. The maximum here is 2, so 2 to the power of 2, and the minimum here is 1, so you just times 1, so that's why it's just 4. And 2, 4, the maximum here is 4 square, that's why we have to apply square on the maximum, and times the minimum, which is 2, and that's why we get 32, and 1, 4. 1 is the minimum here, so you just time 1, and then 4 is the maximum here, and we need to 4 to the power of 2, and then we times them together and we get 16. And 2, 1, 4, the maximum here is 4, so we have to do 4 square times the minimum, which is 1, so 4 square times 1 is 16. And we add up all of these things and we will get 141. That's how this 141 is coming from. So let's see how can we actually solve this problem. So one naive way to solve it is just like what I have explained, just from 001 all the way to 111. Basically, we iterate all the bit string, and for each bit string, and we find which value are included. For example, like 011, and then we'll get something like 14, and then we will just find a minimum inside this 14, which is 1, and then the maximum is 4. That's why we apply 4 square times 1, which will give us 16. Then we repeat for every single bit here, and that will give us the first brute force solution, which the time will be 2 to the power of n, which is exponential, and then also times n, because after iterating everything, which is 2 to the power of n, and then you also have to iterate the subarray or the subsequence again to get the minimum and maximum and calculate the corresponding value, and then append that to our sum, and then eventually return that. But this solution works, but it is too slow when n could be 10 to the power of 5. So can we do better? Let's try to sort the input and see what we get. For example, we get 214 and then you just want to convert it to 124. Now, if you look at this sorted input, there is some interesting property that when we iterate from the smallest to the biggest, and each time for example, we treat these 2x the maximum and we try to match all the minimum that these 2 can match when the 2 is the maximum. And because we are visiting from smallest to biggest, everything that these 2 can match with the minimum should already be seen, right? Because we are visiting from smallest to biggest, nothing here can be matched with 2 such that 2 is the maximum, right? So that's why one intuition that we can get is to sort the array and then iterate every single element, and each time we treat the element as the maximum and try to match the minimum for this maximum element. So one obvious case is that when we try to treat these two as the maximum, for example, the first thing is that it can match with itself. So if it matches with itself, then it's just going to be current squared, because it is the maximum, times current again. Because this is the maximum and this is the minimum, it's matching with itself. That's why it just gave us current to the power of 3. So that is one easy case. Another not so easy case is when we want to match something that is on the left hand side. Let's assume there is a variable called m, which represents all the sum of the minimums that curve can match. So if I'm visiting 2 and the minimum I can match is 1, right? So I can match all of the 1 here, which will give us the answer for matching anything on the left. But when we move to 4, for example, how should we update m? Well, the first thing to update is that m should be plus equals curve, right? Because previously we haven't considered 2, we haven't considered curve, but when we are resetting the next element, because the next element is going to be larger than us, so m is going to include curve, because curve could be a minimum now. But there's more. Remember how we treat all the match as a bit string. So imagine there is a lot of bit string, that's something like this, 0 for example, like this, and these are all the m or the previous m that we can match. Now we consider current, and one possibility is to include current into the previous minimum match. So if we include current, all the things will add 1 inside at the end, because now we include current. But there is another possibility, is that we don't want to include current, we can exclude current. But even if we exclude current or include current, this m can always match with the next larger element. That's why we have, for every possible match before, we can either append 1 or 0. That's why there are like 2 possibilities for every previous match. That's why all the previous match m should be m times 2. So in total, how we're going to update m is that we're going to update m as m equals to m times 2 plus current. So that's how we are going to update m. And now we have the m. It's actually easy to calculate the not so easy case from matching all the things from the left, which is just curve square times m, which is what we want. And combining these two will be all the match that this current can make when current is the maximum. And then we iterate every possible from smallest to biggest and treat everything as the maximum, and then accumulate the answer and eventually return it, and we will get the answer. Yeah, that's it for the overview, and let's see how we can implement it. First, we're gonna initialize a bunch of variables. The first one is the mock, and the second one is the answer we're gonna return, and then the third one is the m, which means all the minimums that current compare, as we discussed. And we're also gonna initialize 2 helper method, just basically add a multiplication, but consider the mock into the calculation. Then we're gonna sort the number first, as we discussed, and then we're gonna iterate every numbers and try to treat x as the maximum and try to find a minimum pair for this x. And first thing we're just going to do on line 11 is to calculate x squared and match it with all the minimum that we have seen. And on line 12, it's just considering it to match with itself, so it's just x to the power of 3. And after considering x, then we have to update m for our future use. So what we have to do, as we discussed, you just have to multiply m by 2 and then also add x into the consideration. And eventually we're just going to return answer. So that's pretty much all for the code, and let's try to submit that. Okay, accepted. The time complexity is O n log n, because we have to sort it in here, but after that we just linear iteration, so that would be n log n. And for spaced, we don't use any space here, but it is debatable whether we're gonna use any extra space in this line 8 while sorting, because we're basically changing every position of the nums potentially. So you can say that it is O1 if you don't consider sorting as taking extra space, but I would say it is ON because you have to change the input already. So that's it, and I will see you next time. Bye bye.